In this tutorial video, I am going to take you through how to create your first gameplay experience in Unreal Engine. For context, the game we are going to be creating in this video involves your character, the one which we used from the previous tutorial, running around in the environment, collecting coins, and then the coins are being updated on the viewports. And then when the player successfully collects all the coins and the viewports and gets to the checkpoints in the level, they are going to win the game. And the character is going to perform a victory dance when they win the game. This is the game we are going to be creating. Without further ado, let us get started. Now, before we start creating, we need to download some assets that we need to make this gameplay possible. Firstly, you should go on Mixamo and let us search for a dance animation that we can use when the player wins the game. These are the various dance animations that we have. So go through this and find which one you find more interesting. I think I like, let's see, let me go through this. Okay, I think I like this chicken dance animation. We are going to play this animation as a montage when the player successfully collects all the coins in the level. So I'm going to download this. So click the download button and download it without scan. Once your download completes, you should import this animation into your projects. I have already launched the game. I've prepared the level of the game. So if I play the game, this was where we stopped from the last time with this same character. We can walk around, we can run around, and then we can jump. These are all the functionalities that the character has right now. But right now, we don't have any thing to engage the player with. The only thing the player can do is just run around and jump across these gaps. So in order to make this more interesting, we are going to place some coins on these blocks so that the player can run and collect them. And then when the player gets to this last block, they are going to win the game and they can perform this chicken dance in the end. Now let us see how to build the system. So firstly, we are going to need the coins that we will place in the level. So download the free coins. You can go to, let's say, sketchfab.com. You can find a lot of free models to use for your project here. In the search bar, I am going to search for coin and choose downloadable contents. You are going to be presented with a lot of results here. So go ahead and find which coins you want to use for the game. I think I like this stylized coin a bit better. It looks simple and, it looks fun. So if you scroll down, you can find the download 3D model button. And I'm going to download this as an FBX file. Now the coin has been downloaded. Then let me move this coin model into my project folder, which I already put here. So I'll create a folder and call this coin, and then I'll copy and paste the asset there. So the texture, this is the texture of the coin, and this is the FBX file for the coin. Now back in Unreal Engine, I'm going to import this coin into the props folder, into the coins folder. Now, because this coin is a static mesh asset, we need to make sure we allow Unreal Engine to import static mesh. Under this static meshes option or tab, I'm going to enable import static meshes, and then I'll click import. And now the coin has been imported for us. But as you can see, this coin does not have its texture. So I'm going to create a new folder called materials. And within this folder, I'm going to create a new folder called textures. And in the textures folder, I'm going to import the texture file for this coin. Then I'm going to create a new material to assign to the coin. If you right click and choose materials, we can rename this and call this m_coin. I will pre-assign this material to the coin by coming under this static mesh editor in the details panel and search for the coin material I just created. Then if you double click the material to open it, we can assign the texture map that we imported. So open this, drag it into the material editor, and then connect this as the base color. I want my coin to look like a shiny metal, so I'm going to increase the metallic to a value of 1. I'm also going to reduce the roughness to, let's say, 0.25 so that it looks shiny like this. Then if you click apply and then save, and now if you preview this, the coin has been added to the coin texture has been added to the material. I could also add some emissive to the coin so that it glows in the level. So here, let us create a multiply node, and then we're going to multiply the diffuse color of the coin by a scalar value and use that to drive the emissive color. So if I set the scalar value to a value of 1, you can see that the coin now glows. So I think I like this. Then I'm going to apply once again and click the save button. Now our coin asset is ready. The next thing I would like to do is to create a blueprint representation of this coin. So let me quickly organize the folder by creating a folder called mesh, and then I will move the materials and the coin into that. I would move the coin mesh into this rather. Then let me create another folder called blueprints. Within this folder, let us create a new blueprint class. And this time around, we are going to make use of actor because this is an object that we want to place in the game world. Click the actor and give it a name. If you double click to open the actor blueprints, it looks similar to what we've seen in the previous tutorial with the character blueprints. But this time around, we are using this to handle the coin functionality in our game. The first thing I would like to do is to add the scene root components, and I will drag this and drop it on this so as to make this the new root of the scene. Next, I am going to add a static mesh component, and I will call this static mesh coin like so. Then if I select the static mesh, under the static mesh in the details panel, I can search for our coin assets and put that in the game. So now our coin mesh has been added to the blueprints. Now, to make it possible for the character to collect this coin, I'm going to make use of a trigger volume. A trigger volume is a volume primitive in Unreal Engine that we can use to create trigger events in our game. For the purpose of this example, I am going to add this trigger volume as a volume such that when the player runs into the trigger volume, it is going to automatically collect this coin for us. So to do that, let us add a sphere collision component. So a sphere collision component is an example of a trigger volume that you can add. Now, if I take this, I can scale it up a little bit. Let's say, let's scale it up by this amount. And I can actually, I can move the coin mesh itself to fit within the volume of this sphere collision. I can also parent the coin mesh under the sphere collision, and let us rename this as our trigger volume. Compile and save. Now let us place these blueprint actors in the level. We can quickly duplicate the placement of this by holding down the Alt key on our keyboard, then click dragging from the blueprint actor we already placed. Now we can do this and quickly populate our level with the coins. Now we have a total of 4 coins in the level. Now, if I play the game and try to run into them, you can see I can't actually collect them just yet. There's a collision between the character and the coin meshes. So this is because we've not yet defined the behavior of these meshes when the character runs into the trigger volume. To do that, I'm going to open the blueprints class for the coin once again. And in the event graph, I'm going to get rid of all these nodes. What I want is that when the player runs into this trigger volume, it is going to automatically destroy the coin from the level so that it disappears. To do that, select the trigger volume. In the details panel, scroll down until you can find on components begin overlap. Click the plus button and then we'll be presented with this trigger event for the trigger volume. What we would like is the moment the player character overlaps this, it destroys the coin. So to reference the player character into this blueprint, we are simply going to go from here and perform a cast. So cast to BP player character. So basically the way I like to interpret this cast node is you are bringing in a reference of the player character into this coin blueprint. That way we can use this player character to interact or do something in this actor blueprint right here. So now what this logic right here is saying is the moment the player character overlaps this trigger volume, and see we are choosing this other actor as the object for this our cast node because the character blueprint is the other actor that we want to specifically overlap with this trigger volume. When the player overlaps this trigger volume, what we want to do is to destroy actor. And if we compile and save, and let us try that, if we run around in the level and the moment we overlap, now you see that the coin gets destroyed. So that means it is working precisely as we want. Now, to make this a little bit interesting, because right now the coin is just like standing still, and when we collect it, there's nothing interesting happening. We can actually play a coin collection sound such that when the player collects the coin, we hear the coin collection sound. We can also add a simple particle effect that dissolves the coin just to make it a bit more interesting. Firstly, let us take care of the sound effects. So to download the free coin sound effects, you can go to this website called zapsplat.com, and here you can search for the coin sound effects you want and then click this download button. To be able to download this, you need to actually register an account with, you need to create a basic user account so that you can download a free MP3 version of this sound effects. So go ahead and register so that you can download the sound, or you can also use sound effects from some other sources that you know of. Back in the Unreal Engine, I've already downloaded the MP3 version of the file. So I'm going to import the coin sound effects. And if I play this is what we have. Now I'm going to place this sound effects in a completely different folder in my project called audios. So everything associated with sound will go into the audio folder. So I'm going to come here and I'm going to move this into the audios folder. Now, if I go to this place, I can create a sound cue out of this so that we can use it for the game. If you select the sound wave, right click, and then you can create a sound cue out of that sound, and you can call it sound cue coin. If I open this up, this is what the sound cue looks like. So the sound cue allows us to add some additional effects or mixing to the sound or to the audio file so that we can, get more variations. So what I would like to do is to add a modulator node so that we can get varying pitches and volume in the coin. So I'm going to just make use of the default settings and click save. Now back in the coin blueprint. So here this is the order in which I want this effect to go. When the player character overlaps the trigger volume, I want this to play out a sound. So let's add a play sound to the node, and then we can search for our coin sound effects. And then if we connect that and try it now, you see now that we hear the sound effects. Another interesting thing that we can do is to spawn some particles at the point of collection so as to make this a little bit more interesting. In my project folder, I'm going to add a new folder called FX. So everything associated with effects is going to be stored within this folder. Now inside this folder, I'm going to create a new Niagara system. So the Niagara system is used for creating different kinds of visual effects for your game projects. So let us click this, and in this create window, we have the option to choose from existing templates. So what I would like to use is this one called omnidirectional burst, and then let's click create. I'm going to name this burst effects. Now if you double click this, let us see what it looks like. So right now you can see the way the effect is happening. So it plays out and then it falls under gravity. I don't want to have gravity on this, so I'm going to disable the gravity in this emitter node. Also, I can change the emitter state, to, I think this is fine as it is. I can also change this from CPU to GPU and then choose fixed. So this way the effect will be based on the GPU of your computer. Now for the spawn bursts instantaneous, I'm going to increase the spawn count to, let's say, 300 so that we have more particles. So if I play that, now you see that we have more particles being spawned. Then in the initialized particle, we can adjust the lifetime of the particles being spawned, and you can also adjust the sizes. The only thing I think I will just do here is to change the color from the default white to the golden yellow color, just to match with the coin. So something around this color seems fine. If I play this now, now we have this golden bright coin that is spawning, the burst effects. Then there are so many other things you can do, but I think for now I'm just going to use this as it is. So once you are happy with your burst effects, save this. Then in the coin blueprints, when the player collects the coin, we want to play a sound, and at the same time we want to spawn this burst effects. So to spawn a particle effect, just add the node spawn system at location. So we want to spawn this effect at the location of the coin. And the effect that we want to spawn is called burst effects. Now this location is asking us what location do we want to spawn this effect at. Since we want the effect to be spawned at the points of collection of the coin, we are going to get the actor's location. So the location of this actor in the level is going to be used as the location where the particle effect is being spawned. And if we compile and save and try that out, now we have the effects working precisely. So we can come here, and also you can see that the modulator we added to our sound effect is also taking effects. And now it's looking a bit more interesting. Okay, this is looking good. Then I'm going to highlight this and just call this overlapping logic. Or maybe to be more precise, overlap logic for coin. Okay, so this is looking good. Now, one more thing I would like to do for the coin is when I play the game, you see that they are just standing, still. I actually want them to be rotating by default, just to give it a little bit more visual appeal. So to add that rotation to the coin, I'm going to add the rotating component or a rotating movement component in the components window. So by adding this, it's automatically going to start spinning the coin. So let us see how that looks like. And as you can see, the coins are now spinning, and then I can run into them, collect them. So this is working as we want. Nice. Okay, so maybe I'm going to place one more coin on the last block. Now, the coin interaction is working precisely as we want it to be. Let me select all these coin actors here and group them into a coins group. So this is just to organize our outliner a bit better. The next thing we would like to do is for the player to dance, the dance animation we downloaded earlier when the player successfully collects all the coins. Firstly, let us see how the animation itself will work without, connecting it to this coin collection system we have so far. If I open the animation folder, we can actually import the animation. So I haven't imported it here, so let's just click the import button and let's look for the dancing animation. So I have the chicken dance animation right here, and then I'll open it. Then make sure you disable this since we are importing an animation. Then I'm going to choose the character rig and I will click import. Now this is what the chicken dance animation looks like. Now we want this animation to play automatically when the player successfully collects all these 5 coins. But before we do that, let us first see how we can play the animation itself in the game. Now, remember in the last tutorial, we made use of the animation blueprints to handle the locomotion and the jumping of the character. But this time around, we want to be able to play the animation, without necessarily overriding the locomotion that we've done. So a very good solution to doing that is the use of animation montage. So animation montage are just animations that you can play at any point in your game, whether by triggered events or by other means during the runtime. And it will not affect whatever base animation that you've done. To be able to play an animation montage, we need to add a new node to this anim graph called default slots. So this default slot node is going to make it possible for us to play animation montage in our game. As long as this is added before the output pose, it will work perfectly. Compile and save this. The next thing we would like to do is to go into the animation and actually convert this animation, this dance animation, into an animation montage. Right now it is an animation sequence. So to convert this, let us first create a folder to store all our montages. Then select this chicken dance, right click and go to create anim montage. Now our animation montage has been created. Then you can drag this and store it in this montage so that we keep things organized. Next, let us open the character blueprints and see how we can play the montage. For the purpose of this, let me use a debug key. Let's say debug keyboard, let's say E, for example. So what I want to do is when I press E, I want that chicken dance animation to play in the game. So every time I press E, I want this chicken dance to happen. So to do that, just go from pressed and search for play anim montage. Now you'll see that there are two types of play anim montage nodes that we have here. Personally, I like to make use of this first one because it allows us to perform some extra things during the montage. Now for the in skeletal components, in skeletal mesh components, we are going to add the character mesh. Since this is the mesh that contains the skeletal assets, where the animation data is being driven from. And from the montage to play, I'm going to choose the chicken dance. Now, if I play the game and then I press E, now you see that it starts performing the chicken dance. But notice something, if I perform the chicken dance and then I move around, you see that we are moving around while performing the chicken dance. We actually don't want this. We want it to only perform the chicken dance while standing still. We don't want the character to move around. So we could limit that by adding a Boolean condition. So the Boolean condition we want to add, we want to check firstly if any montage is currently playing on this character mesh. And to do that, let us drag in the character mesh. From here, we are going to get an animation instance. So this animation instance keeps track of everything associated with the animation on the skeletal mesh component. And from this, we are going to search for is montage playing. So let's just say is any montage playing for now. Also, we don't want to play the montage if the character is falling down. So from the character movement, we are going to get is falling. So if the character is falling, or if an existing animation montage is playing, we don't want to play the montage. So that means if the character is falling or an existing montage is playing, we do not. So if this condition is true, we don't want to play the montage. So, but if these conditions are not true, that is false, we want to play the montage. But let's use a not boolean, because I actually like to run my code from the true, usually whenever I work with the branch node. So I'm going to add the not boolean here, and then I'm going to add another one here, just so that we can make use of this true output pin. Now let me quickly organize this node a little bit better. So here we are going to comment this and say check if character is falling or existing montages are playing. So if these conditions are true, we are going to play the montage. Then to take care of the fit sliding problem, we are going to also get the character movement, and then we are going to disable movement on the character. So this disable movements will make it impossible for us to move when the montage is playing. But when the montage finish playing, we want to be able to move the character again. So I'm going to copy this, and on completed, that is when the montage finish playing, I'm going to set movement mode. And the movement mode I would like to set is walking. So we are going to change this back to walking when the player character finish when the character finish the montage. So I can also comment this and say disable character movements, play montage, and we enable walk mode after montage finish playing. So I can just comment it that way just to help us keep track of what is happening. So this is the logic. Now if I compile this and save and then play the game, now if I press the dance, I'm trying to move around, but it's not moving. So I can only move around when the montage finish playing. So that is what we want for this case. In a separate video, I'm going to really focus on the different things we can do with animation montage. We are going to really do a deep dive into montage, but for the purpose of this video, we are just trying to create a game whereby when we finish collecting all these coins, it automatically performs this chicken dance. Now, what is the next thing we would like to do? Well, we need a way to keep track of how many coins that we've collected so far. So every time the player collects a coin in the level, we want to be able to keep track of how many coins has been collected. So if I collect this, I want it to tell me that I've collected 1 coin. If I collect this, it's going to add to the previous score, and so on and so forth. So how do we do that? Well, in the character blueprints, we are going to store the coins into an integer variable. So let us create a new variable and choose integer type. And then I'm going to call this current score. So this score is just like how many coins the player has collected so far. So current score. Now, what we could do is let's set the default amount of coin here to 0. Then let's also add another one called max score. So the max score is going to be the total amount of coins that are available in the level. Now, from when the game starts, what we want to do is to make the game count how many coins are already in the level and set that amount to our max score. So in order to do that, we are going to follow this approach. From event begin play, this logic is going to run off event begin play in the player character. So from event begin play, let us get all actors of class. So this get all actors of class nodes is going to get a reference to every real object, or each of these objects that are in the level. So the class that those objects belongs to is called BP underscore coin. So every actors that belongs to this BP underscore coin are going to be derived. Then what we want to get from this out actor, because this is an array, is going to give us like an array of all of them. So we are going to get the length, that is the total amount of that array, and we are going to set that as the max score. So if I highlight this, I'm going to say initialize max score. So we are basically getting the amount of all these actors and setting that as our uh, max scores value. Now, to be able to actually see the score on the viewport, like in the screen when I collect the coin, we need a widget to display the score on the screen for us. So we are going to create a new widget in this widget folder to be able to, display the player score. To do that, right click and go to user interface widget blueprints. And then we are going to create a user widget. I'm going to rename this WBP underscore score. Then double click to open. So the first thing we would like to add here is a canvas panel. So the canvas panel is going to be a representation of the screen. So this is like the representation of the player screen. And then we can design the UI depending on where we want to, where we want the UI elements to be displayed. For the score, I'm going to make use of a text component. I'm going to drag that under the canvas. And now we have a text block right here. I would like to actually display the score at the top center of the screen. To do that, I'm going to come under this anchor and choose the top center anchor right here. But you see that our text block is still back here, even though we are now at the top anchor. So we need to zero out this value, and then it snaps to that point. Also, I want this to, be properly centralized. So let me first enable size to content. And then for the alignment, I'm going to set it to 0.5, 0.5. Now the text align properly with the anchor points. Then you can just move this down maybe a little bit and zero this out. And now wherever we place this is where the text block is going to be displayed. Now, before we do anything, let us see how to actually add this widget to the screen. So we could use a manager, or we could do that directly in the player character blueprints. In some later videos I'm going to show you how you can use blueprint managers to automate a lot of processes in your game. So it's actually a very good practice that keeps things organized and keeps your blueprints easy to track. But for the purpose of this example, let us just do it within the player character blueprints. So from the event begin play, the first thing I will do is to add or to create this widget that we just created. So let's add the create widget node. And the widget we would like to create is called WBP underscore score. Then I would like to promote this as a variable so that I can have access to this. So let us call this score HUD reference. So, and from here, I can now add to viewports. So using add to viewports is basically going to add this widget to the screen at runtime. So if I comment this, I'll call this add score widgets. And if I compile, save, and play the game, now you see that the text block has been added for us. But right now, it's kind of difficult to see because of the background colors. So let us add a background for this text block so that we can see it much easily. What I would like to do is to add another common editor called this one called borders. So I'm going to add a border. Okay, maybe instead of border, let's use an overlay, for instance. So I can add an overlay, and I'm going to anchor this overlay at the exact position of this text. So 0 0.5, 0 0.5, and then let's move it down like so. Then I can also resize this, let's say 300 by 100. Okay, maybe that's too much. Let's say 75 or maybe 70. So something like that. And now this overlay allows us to stack multiple widget components on top of each other. So I'm going to add this text within the overlay. And the moment I add it, you see that the position changes. But don't worry, we can get it to be centralized perfectly within this overlay by clicking this centralize alignment buttons right here. Then to add a dark background to the text, I'm going to add a border, or you can also use an image, whichever one you prefer. So if we add that and then we scale this to fit, let us change the color of this to black, and then I'm going to drag it on top so that the text is going to be in front. So the way this widget layer thing works is whatever is down here is usually the frontmost layer components, basically. So I'm going to reduce the opacity of this background a little bit. Let us say maybe 0.7 or something, just so that it's not entirely plain black, so that we can still slightly see through. So if you compile and save, and let's try that again, now the text is properly visible on the screen. Next, what we want to be able to do is to let us replace this text block text with the actual text information that we want the player to see. And we can do that right in the widget blueprint itself. I'm going to select the text components, and under this content tab where it says text, we are going to add a function. We are going to bind the function to this text contents so that whatever we define in this function is going to be what we see in the game. So let's create a new binding. And for this, I'm going to create two new variables, integers as well, similar to the two variables we created here. So I'm going to call this current score. And then I'm going to call this max score. From this place, I'm going to add the format text. So this format text allows us to format how we want our text to be displayed. So what I would like to do is to type in score. Then if you use this curly brackets, we can actually add like input to this. So if I add score, then curly brackets, then over curly brackets once again, max score, and I hit enter. Now this is going to create two new inputs for me based on whatever I type in here. So as you can see, so if I set this, let's compile this so we can set a default value. So let's set this to maybe 10, for example, and set the maximum to, let's say, 20. And now if I connect these two right here, if I connect these two right here, and then I compile and play, you see now that the format that we typed in that has now, replaced the text we had earlier. But we do not want to update the text here, because we don't want to update the current score and max score here, because this widget has no idea what we are trying to do here. So let me highlight this and just call this bind text functions, or bind text function. So what we would like to do is to actually set values on these two variables here from the player character blueprints. Now remember, we already added the widgets within this place. So one thing we are going to do now is to set the max score from the player variable to the max score in the widgets. And to do that, I'm going to drag off my, maybe I could bring in my reference, and then I'm going to set max score. So we have access to that variable. So this max score is coming from the widgets. So we want to set that value to the max score that is coming from the player character blueprints. Now let's call this initialize max score. And this makes sense because we are first setting the max score right here, and whatever value we set here is also going to be piped into this max score from the widgets. Then now if we play now you see that the max score is set to a value of 5. Don't worry about this score for now. Maybe we can just initialize that as well. So from here, let us also initialize set current score. So the current score is going to be equivalent to whatever value the current score is from the player blueprints. So let us set current score like so. And then I can call this initialize max score and current score. Now, if I compile and save, now you see that the current score has been overridden by the current score from the player. So this is what we want to have. So the score is 0/5. And that is how you can quickly add widgets to your gameplay. The next thing we would like to do is to update the current score every time the player runs into a coin. So every time we collect a coin, we want to update the current score. Now to do that, we can do that from the BP coin itself. Remember that we are casting the player character in the coin blueprints. So maybe something I could do is to add a teeny tiny delay here. I mean, this doesn't really matter, but this is just to, to allow for some runtime gap. So I could add maybe a very tiny delay so that everything works without issue. And what I would like to do is to update the current score from the player character each time the player overlaps this trigger volume. From here, I am going to get the current score variable, which is in the player character. And then I am going to increment it. So this increment is going to increase the value of this score by a value of 1 and then update it as well. Or traditionally, if you want to do it traditionally, you can just use the add. You can use add. So every time we collect a coin, we add the value of 1 or whatever value you want, and then we are going to draw from here and say set current score once again, and then you set the current score. So either you do it this way or you use the increment node. They both do the same thing. And to also make sure that this score updates on our widgets, remember this one is just updating the current score in the player character, but we also need to update it on the widget so that it actually shows on the widgets when we collect a coin. Now remember that we already have a reference to the widgets in our player character. So we need to first get a reference to that widget. And from here, we can now set current score from that widget. And the current score is going to be set to this current score value from the player. And now let's connect this. So this ensures that our score always updates in the widgets each time our player collects a coin. Now, if I compile this and save and test the game, so let's go and collect our first coin. Now you see that the score updates. So if I collect the second one, it's updates again. And then if I collect the third one, so now this is working exactly. So this is working exactly as we wanted. Now, That's good. Finally, to conclude this tutorial, the last thing we'd like to do is when the player collects this last coin, we want him to perform the chicken dance. Now, for this, we are going to constantly check this score variable because the variable that will be responsible for playing the chicken dance animation is, or the condition rather, that will be responsible for playing the chicken dance animation is if the player has collected all the coin in the level. So if the player has not yet collected all the coin, the chicken dance will not happen. But if the player has collected all the coin, then the chicken dance will happen. So to do that, we need to continually check this current score variable in the player character. Now let me just disable this since we don't want to trigger this dance by ourselves, but rather we want the game to automatically play this chicken dance montage once that condition we talked about earlier is met. And I can even get rid of this since those was just done for demonstration purpose. But I can still keep this disable movement and probably remove this since we want the game to end there. Now, to continually check for the variable, we are going to make use of the event tick. Or not event this, event tick. So the event tick is going to evaluate on every frame during the game runtime. And we can use this to constantly check if this current score is equal to this max score. So to do that, let us use a branch node. And the condition we want to check is if the current score is greater than or equal to, I mean, you can also use equal to, but I just prefer to use greater than or equal to because it seems more intuitive in a way. So if this is greater than or equal to the max score, if this is true, we are going to play the chicken dance. Now, you have to be careful here. Remember that this event tick node evaluates your code on every frame. So if we connect it like this, it is, if we connect it this way, maybe I can reuse something else. If we connect it this way, this is going to trigger this montage every frame, and we don't really want that. What we want is for this chicken dance animation to play once rather than, every frame. So to prevent that from happening, let us add a do once node. This do once node is going to run this code, whatever code we connect here is going to run it just once, and it will ignore whatever incoming code that's that is happening from this input. So we want this to just play the node once. Then at the same time, we can, rather than disable movements, we can actually get the player controller and disable inputs. So the reason why we are doing this is just so that the player will no longer be able to control the character again. So this will be the ending of the game. So we can disable inputs, and that will be the ending of the game. We are going to modify this a little bit shortly, just like to add some options to be able to restart or quit the game. But let's just see, and let's just see how this condition works. So this will check if current, okay, let me just put this as check condition. Yeah. So, and then this we can say disable inputs and play dance montage. Now, if I compile and save this, let us play the game once again. So if I go collect all the coin now, now you see that we perform the chicken dance. And that is precisely what we want. But now notice that after the chicken dance finishes, we cannot do anything again. So the input has been disabled because of what we had here. So something we could do is to create another widget that displays, the victory for us. So when the player wins, it displays that widget. So let's create a new widget uh, to do that. So we are going to call this WBP. Let's just call this win screen or something. And we open this just like before. We are going to add the canvas panel. Then we would like to blur the background so that the background is blurred out. So I'm going to scale this to fit the entire screen, and I will zero this out so it fills the entire screen. Then I will increase the blur strength to, let's say, a value of 10, just so that it's blur. And then I'm going to add some buttons that we can click on this widget so that when you click it, you can restart the game. And so we have the option to restart the game, and we also have the option to quit the game. So let us add some buttons. So let's call this b underscore restarts, and let us call this b underscore quits. Now let's think of how to arrange things. So because right now I'm just dropping the widget component. So to make this a little bit more organized, let me add another overlay so that I can stack things on top of each other. And I will move this overlay in front of the background blur so that the overlay is in the front. Then let's centralize this so that it's at the center of the screen. And I can put this at 0.5, 0.5. Then for the size, let us define a size for this. Let's say, or maybe we can even size to content so that whatever we put within this overlay is going to automatically resize to fit. So for example, if I drag in this tool into the overlay, now it sizes up based on what we have there. So maybe actually I think it would be nice to just resize this overlay so that it's looking a bit better. So if I disable this and change this to, let's say, maybe 600 by 600 or something. So this is where whatever button we want will be displayed. Now we can add these two buttons. So another component I'll actually add to make this a bit more organized is I'm going to add a vertical box. The vertical box will allow you to stack things on top of each other within. So whatever you put in the vertical box, they'll be stacked on top of each other. So I'll put in the quit button, then I'll put in the restart button. So, and then I can put in some padding, like some gaps between both of these. So let's put in a padding of, let's say, 15, for example. And for this, I'm going to also add a padding of 15. Then I could also add a text just to display you win. So let me put the text at the top of this. So the text is at the top. I will centralize it, and maybe, okay, let's use auto. I'm going to change the text to you win. So this is the text that displays to the player whenever they finish collecting all the coin. And I can set the size, the font size to, let's say, something a bit bigger, maybe 80. Just feel free to play around with these things to get what you want. So let me put the top padding like so. Then for this button, I'm going to add a text to label them, just so that we know what each buttons are doing. So let me actually increase the padding here a bit to, I don't know, just so that things are centralized a bit better. Let's say something like that is fine. So you win. Then the text we would like to display, let's change the text color to maybe black. Yeah. Then I'll change this to restart game, and then I will change the other one to quit game. So these are the buttons that will be displayed on the screen. Then what I would like to do is to add a logic for each of these buttons such that when the player actually click them, in the game, they do something. So we can do that directly in the player blueprint, or we can also we can write the logic in the widget itself. So for this case, let us write the logic in the widget itself. Now to make it possible to be able to like write logic for this, we are going to make sure we enable this checkbox called is variable. So that will make it possible for us to write events for the clicking of the buttons. And if you scroll down, now we have this event available for us. So I'm going to click this on clicked events. I can get rid of this. So when the player clicks this button, we want to restart. And the way we will restart is by simply reopening the same level once again. So when the player clicks it, we are going to reopen the level. And the level we are opening is our current level, which is this game prototype. So I'm going to look for the level here. So when the player clicks it, it's just going to reopen. So maybe I can add a little bit of delay just so that it doesn't open immediately. Then I'm going to also add a logic for the quit button. So this quit button, when you click it, is going to basically quit the game. So this is what the buttons do. So I will just call this buttons logic. Now let me compile and save. Now remember that here when the input is disabled and the montage plays, we don't get to use this input on the player again. But what we can actually do is to show the mouse cursor so that we can use it to click the buttons on this wing widgets. So when the montage finish playing, what we would like to do is to first set show mouse cursor. So we are going to show the mouse cursor and set this to true. So as long as this is true, then we'll be able to use the mouse cursor to click the widgets. Now we can quickly add that by coming back to our events begin play, and then we are going to create widgets once again. So we create this widget windscreen, WBP windscreen. We won't add this to the viewport just yet. We need to make this a variable. So let's call this windscreen HUD reference. We do need to make it a variable because we don't want to add this to the screen the moment the game starts. We only want to add this when the dance montage finish playing. So we are going to come here and bring out the screen reference, and then we add to viewport from here. So when the montage finish playing, it is going to add this to the viewport, and then we are going to see our mouse cursor. So let's say add wing screen. So viewports. And now our logic is complete. So if I compile and save this, and then let us play the game. So collect the first coin, collect the second coin, third one, and the fourth one. And now it does the chicken dance. So you win. And then these buttons become accessible. So if I click restart, it's going to restart the game, and then we can go again, collect the coins again. And then we do the chicken dance once again. And now this is working exactly as we want. So if you click the quit button, it's going to automatically quit the game. And this is exactly what we want. So I hope you have been able to learn some things from this tutorial video, and I hope now you should be confident enough to be able to build your own simple game logic. And if you really like what I do, I would really appreciate it if you can support me by subscribing to my channel so as to encourage me to do more useful contents like this in the future. So thank you for sticking to the end, and I will see you in the next video.